Hello everyone, welcome to Technologies Discussion channel. Today, I'd like to continue the discussion on antenna. So for this video, again, I'm going to emphasize on the key parameters of antenna. This video, I'm going to define what is actually front to back ratio. I'm also going to define what is actually front to rear ratio. Next, I'm going to highlight the key difference between these two terms. Okay, so these two terms is actually quite similar. This video, in fact, I will describe what is front to back ratio, and with the knowledge that you actually understand, you can easily apply to understand the concept of front to rear ratio. Last but not least, I'm going to do a simple calculation. Okay, how can we actually compute the front to back ratio and also the front to rear ratio? So this will be the objective of this video. This will be the part 12 series discussion on antenna. So guys, if you're keen to know more about antenna, okay, please take a look on the playlist under the description. Over there, you will be able to find a series of discussion on antenna. This is my email. If you have any question regards on this discussion, okay, please drop me an email. Okay, or if not, if you want to have a faster response, okay, you are always welcome to ask me through the comment. Okay, before I continue, I'd like to urge you guys to help this channel by like this video. Okay, when more of you guys actually like this video will have a higher chances to reach out to a larger audience. So guys, help me, okay, by press the like button now. For those who are new to this channel, please consider to subscribe and turn on your notification bell. Once again, thank you so much for strong support. Okay, so this slides actually shows the key parameters of antenna. So these are all the early on discussion that I've done for these antennas. Next, this video, okay, I'm going to focus on front to back ratio. As I mentioned earlier on, with the knowledge that you actually so-called obtain from this front to back ratio, you should be easily apply to front to rear ratio. And then basically you will fully understand, okay, what will be the key difference between these two definitions. Let's quickly understand what is actually front to back ratio. Okay, so this slide here, okay, I'm going to explain the key difference between front to back ratio and also front to rear ratio. Let's come to the definition of front to back ratio. Okay, so this front to back ratio is the ratio of the maximum power radiated out by the antenna in the forward direction. Okay, which means that when you actually have an antenna, the power that is actually radiated out in a forward direction. So basically, this is what it means over here. Next, this power, which is the maximum power radiated by the antenna, is over to the power that is actually radiated in the opposite direction. So in short, you just imagine that the power that you actually radiate up by the antenna, let's say is 0 degree. So the real or the back is actually the power that is actually radiated up at 180 degree, okay, which means that the opposite direction. So basically, in short, the ratio between these two power will show it to you what will be the value for front to back ratio. Okay, so it actually measures the power difference between the front and the directly opposite side of the antenna, okay, which means the 0 and 180 degree. A high front to back ratio also implies strong forward radiation and low radiation in the opposite direction, which means that most of the EM wave actually propagate in the forward direction, okay, if you have a high front to back ratio. Now let's quickly come to front to rear ratio. Okay, so the front to rear ratio is the ratio of the maximum power radiated by the antenna in the forward direction, which is the same here. Okay, so basically we want to obtain the maximum power that is radiated out by the antenna, okay, in the 0 degree. Now, okay, this will be over the maximum power that is actually radiated out in the backward direction. Okay, so later on, I will show you a diagram to let you understand this better. Okay, so this front to rear ratio actually indicate the antenna directional gain in the forward direction relative to its backward radiation. Okay, so basically, this is more general term. Okay, again, when we emphasize on a high front to rear ratio, this actually significant strong forward radiation and very little backward radiation. Okay, so next, I think this diagram will let you fully understand what is actually front to back ratio and also front to rear ratio. From here, you can see that, let's imagine this is the antenna. So this is what we call the forward power. Okay, so the forward power actually happen at 0 degree. Okay, so how we define the front to back? So front to back is exactly 180 degree behind. So therefore, the power that is actually radiated out from here over the power that is actually obtained 180 degree, that will give us the front to back ratio. As for front to rear ratio, okay, the forward power is the same, okay, but now, okay, basically you obtain the maximum power from the rear. As you can see from this diagram, let's say this part here is the maximum power from the rear. So again, the forward power versus this power from the maximum at the rear, this will actually let you obtain front to rear ratio. Okay, I guess with this, you understand what I want to say. So like I mentioned earlier on this video, I mainly will concentrate on front to back ratio. Okay, the front to back ratio of an antenna is a key performance metric that measures the antenna ability to focus energy in its desired direction while minimizing radiation or reception in the opposite direction. Okay, which means that this ratio actually will indicate how strong the forward power versus the back power. So basically this term later on, I give you an example why we need to have the definition with this front to back ratio. Okay, so this ratio is defined as the ratio of the power that is radiated or received in the forward direction to the power that is actually radiated or received in the backward direction. Okay, it is usually expressed in decibel. Let's quickly understand this. So this is in term of ratio, front to back ratio. So we actually has this power that is actually radiated forward versus 180 degree power, okay, which is the opposite direction. Okay, so with these two power, we actually obtain the front to back ratio. And if we want to convert into decibel, we just do a 10 log. So then, therefore, this will be in decibel. So over here, I think you can easily apply to so-called front to rear ratio also. They are the same. Okay, so now I'm going to show you a simple calculation. How can we actually obtain the front to back and also front to rear ratio? Okay, so this diagram is much earlier on. Okay, so basically the forward power, as you can see from here, the forward power is actually minus 0.04488 dB. So this is actually the power from the forward. So next, let's say we do this real front to back first. Okay, so when we actually do this front to back here, so we have this value, which is minus 0.04488. Okay, so therefore for the back power is actually minus 15.56. So when we actually take this minus 0.04488 minus 15.56, we actually will obtain 15.52 dB. So therefore, this is actually so-called the front to back ratio in dB. Next, okay, over here, okay, how we can actually compute the front to rear. Okay, so again, the forward power is still the same, will be minus 0.04488. Okay, so over here, you can see that basically this point here will be the largest real power. So basically the real power is actually minus 11.64. Again, I actually will take the forward power, okay, minus away the real power. Okay, so therefore, I'm able to obtain the front to rear ratio in terms of dB. Okay, so now I guess it's much more clear how can I actually compute the front to back ratio and also front to rear ratio. Okay, so before I continue, okay, again, okay, if you have learned something from this video, please help to like and subscribe. Let's quickly move on. Okay, so in a multi-link path, microwave link operate on two frequency, okay, which is known as go and return, okay, which means that they simultaneously transmit and also receive. Okay, on the first hop, we will transmit on frequency F1. Okay, so basically just imagine this is the first hop. Okay, you can see over here, this antenna here. Okay, so there are actually two antenna. Okay, this will be the antenna. The antenna here will be transmitting at frequency 1. So basically this is what I mean. Okay, basically transmit on frequency 1 and simultaneously receive traffic from the far end on frequency F2. Okay, you can see from here, this antenna will be actually receiving at the frequency F2. So this is what it means over here. However, on the next hop down the chain, okay, we will transmit on F2 and receive on F1. So on the next hop, okay, we will be this antenna here, okay, they will be transmitting at F2 and they will be receiving at F1. Okay, so this is what it means. Okay, so this setup means that two back-to-back antenna, okay, which means that, for example, over here, these two back-to-back antenna, okay, so they will both receive F1. Can you see here? They will both receive F1. So therefore, okay, the indicative of front to back ratio is crucial now. Okay, because for this antenna here on the left, they actually want to get this signal. They do not want to get this signal. So therefore, the front to back need to be strong so that I can cancel away this F1. Same for this antenna here, which is on the right. Okay, so the key purpose on this right antenna, they just want to receive this signal. They do not want to receive this signal. So therefore, okay, I need to have a high front to back ratio so as to cancel away this, okay, for the right hand side antenna. Okay, so I guess now it should be much more clearer. Okay, so therefore, the antenna must be capable of blocking the signal received directly behind them to avoid interference. Correctly specified the required front-to-back immunity will prevent this type of interference. Okay, so basically this is what I so-called discussed earlier on. So I need to have a front-to-back ratio so as to cancel anything that is not so-called does not belong to antenna. Like I mentioned earlier on, the antenna on the left, I just want to receive this F1, not this F1. So therefore, with a high front to back ratio, I will be able to cancel this F1. As for the antenna on the right, again, okay, you can see from here, they only want to receive this signal and do not want to receive this signal. So therefore, I need to have a strong front to back ratio in order to cancel away this signal and fully concentrate to receive from this direction. Okay, so basically this is why we need to have a so-called define the parameters of the antenna here, having these parameters, which is called the front to back ratio. Okay, although the antenna at the receiving end of a hop will collect some of the incident radio wave signal, okay, much of the signal will bypass the receiving antenna and continue to propagate through the atmosphere. Okay, so what does this mean? For example, this F1, okay, so basically they propagate, okay, let's say you imagine they propagate in the atmosphere, okay, they will be received by this antenna. Okay, you can also imagine that majority of them will be continue to propagate. Can you imagine this? Majority of them will be still continue to propagate. So this is what you mean. They will still continue propagate through the atmosphere. If this signal will to intercept a different microwave link operate at a similar frequency or another part of the same link, harmful interference could result. Okay, so basically you imagine this wave here, let's say they propagate, and then finally over here, okay, so this may cause some disrupt, okay, on the rest of the antenna, since this is so-called the go and return antenna. So basically this is what it means. So if the signal is strong and they propagate at a long range, okay, this may become a big issue, okay, because they may cause some interference as he mentioned here. Okay, so once they use a similar frequency, for this case, let's say F1, then we will have a lot of interference. Okay, the beamwidth, okay, together with the knowledge of the transmit power. Okay, so if you have not been able to understand what is beamwidth, okay, please see the playlist. Okay, so over there, I have actually described what is called beamwidth. So therefore, when you are able to so-called control the beamwidth, which means that specifically target to this particular antenna, for example, then you actually will resolve the issue of interference. Okay, so but if not, okay, the bandwidth together with the knowledge of the transmit power, they actually allow the link designer to calculate radio wave field strength at any distance from the transmitter across a angular region and thus assess the potential for interference. So basically, we can also use another parameters, which is the beamwidth, okay, so as to avoid interference. Like I mentioned earlier on, this F1 frequency, the signal will be received by this antenna, but you can imagine most of the signal will be still propagate and may become a big issue if another antenna actually receive the signal of F1, and this actually potentially will cause interference. How can we actually improve the front to back ratio? Okay, so key thing we can do is with shielding. Okay, if not, we can add the reflector dish. Okay, physical modification to an antenna, okay, such as adding shielding, okay, on the side or on the back, okay, or if we use a reflector behind the antenna, okay, all this can help to improve the front to back ratio, okay, by minimizing the backward radiation. So basically from here you can see that if we put some form of shielding, okay, or if not, we put some form of reflector, okay, so the front to back ratio will be higher, okay, because we actually minimize the back signal as much as possible since we put some form of shielding or the reflector disc. Even a very simple DIY effort to add in a specific shielding or a reflector dish can boost performance. However, okay, let's say we do it professionally, we meet the shield and reflector, okay, this will definitely enhance the performance. Let's quickly understand, okay, earlier on I have mentioned about this high front to back ratio. Okay, so when we actually have this high front to back ratio, okay, so as I explained earlier on, this actually indicate the antenna is more direction focused, most of its energy in the forward direction with very little interference from signal coming from the opposite direction, which means that most of the energy is actually transmit in the forward, very little is actually transmit from directly opposite. Okay, so next I like to emphasize a little bit on lower front to back ratio. What will happen? Okay, so when the front to back ratio, okay, is actually a very small number, this actually indicate less directivity. Okay, which means that imagine the forward is actually much lesser and the backward is actually much stronger. So basically with this antenna is actually less direction, okay, because they also focus on the backside. Okay, means the antenna radiate or receive more energy in both the forward and backward direction. So basically, in short, okay, this may not be so-called a bad thing. For example, if you want to receive the signal from the front and also the back, so therefore we may even want to optimize the antenna to have a lower front to back ratio. Microwave antenna actually produce a very highly directive beam. Okay, so as you can see from here, so this is a very highly directive beam, which means that we concentrate to send, okay, our EM wave at a particular direction. Okay, as he mentioned here. Okay, so this means that they have a high level of responsiveness in one particular direction. Okay, just imagine this of a torch beam that you actually direct light within a very narrow angular region. So basically, imagine you shine a light, and basically this will be so-called the beam from the light. So basically, this is actually considered very narrow angular region. Okay, in antenna terminology, okay, this region is called the main beam. So this is what we call the main beam, and its direction coincident with the mechanical axis of symmetric of the reflector. Beyond the main beam, okay, the directive actually decrease, forming several small side beam. Okay, so these are all we call the side beam, okay, or side loop, okay, which are much less intensive than the main beam and reduce further in magnitude as the angle move away from the axis. Okay, so from here you can see that beside this main loop, okay, we also have side loop, or we call this directly opposite, we call this as main loop. So basically in short, okay, if we have a high front to back ratio, which means that most of the energy will be radiated out in the main loop, very little on the side loop. However, if we have a lower front to back ratio, this main loop will be smaller, you imagine that, and the side loop is actually so-called significantly much higher. Okay, so therefore, this is the definition of high front to back ratio and also low to back ratio. Let's come to the last slide for this discussion here. The higher the front to back ratio, okay, the more direction effective the antenna. As I mentioned earlier on, a directive antenna always radiates some signal from the back of the antenna. Okay, so basically this is a practical antenna. There is no antenna that only focus their energy purely at one direction only. So therefore, we cannot so-called remove away the effect of antenna, they actually will radiate some signal actually at the back of the antenna. Okay, a long-range directive antenna will have a front-to-back ratio of 15 dBi or higher. Okay, so basically this is we want a so-called a good front-to-back ratio. Then we want it to be at least 50 dBi. So basically with this, we actually can declare that this is actually a high front-to-back ratio. The high gain raise the signal above the signal noise, thereby increase the signal strength. Okay, so basically, if we go to have a high gain, okay, because the beam is strong, most of the time we will have a high gain. This actually will raise the signal above the signal noise. Therefore, they actually improve the signal strength, which means the signal to noise ratio also increase. Okay, so therefore, the front to back ratio, okay, for 34 dBi, okay, basically for a directive antenna, can be achieved by a large dish antenna. So basically, like I mentioned earlier, with proper design, okay, you can see that the front to back ratio can be significantly improved. Okay, the front to back ratio is important in situation where minimizing signal noise or interference is critical. Okay, so earlier on I showed it to you, okay, why we need to have this front to back ratio. Okay, a low front to back ratio indicates that the antenna is less direction, leading to poor reception from the front. However, a low front to back ratio can be advantage when trying to pick up signal from behind or to the side of the antenna. So for example, if you build an antenna, it may not be so-called always pick up the signal from the front. So therefore, when we actually have this low front to back, okay, so therefore the side loop, we can also receive the signal. Even the back loop, we also can receive the signal. So basically, this is what it means. Okay, the key antenna parameters help engineers design system where the majority of the radiate power is direct forward, with minimum power actually lost to the rear. Okay, it is especially useful in direction RF system to minimize interference from the reverse direction. A high front to back ratio is ideal, okay, because it reduces the energy radiated behind the antenna, resulting in a higher overall antenna. Okay, so with this, okay, I would like to end my discussion. But over here, you can see that if you understand the term front to back ratio, you can easily apply this to front to rear ratio also. Okay, so with this, I'd like to end my discussion. Okay, please help to like and subscribe. Once again, thank you so much for strong support. I hope to see you guys soon. Bye for now. Thank you.